Okay, we're looking at some of the homework problems, sample homework problems in 17.2. Let's look at number 4. The curve is the line segment from 1, 2 to 4, 7. Okay, so we have to parameterize it, and that's going to be 1 minus t, and that's going to give us that's our x and that's our y. So we're going to change the variables, and this is going to be from 0 to 1, because whenever you do this, t is always between 0 and 1 when you do this to a line segment. And y then is 2 plus 5t. E to the x is 1 plus 3t. ds is the square root of x prime squared plus y prime squared. And this is dt. So we're just making the substitution. ds is the arc length. This is the square root of 34, 0 to 1. We can do this by parts. Let u be 2 plus 5t, and du is 5. And we keep taking the derivative on this side. Here we're going to integrate. We multiply in the diagonal. So this is going to be square root of 34, 1/3, 2 plus 5t times e to the 1 plus 3t minus 5/9 e to the 1 plus 3t, 0 to 1. So that gives us square root of 34 times 7/3 e to the 4th minus 5/9 e to the 4th minus 2/3 e to the 1 plus 5/9 e to the 1, which is square root of 34 16/9 e to the 4th minus 1/9 e, if you get common denominators. Okay, number 8. Here I have an integral that's mixed, and the curve is the half circle going counterclockwise. That's the first curve. So I can parameterize the circle by cosine t sine t. T is between 0 and pi. And then the second curve, I have the line segment from -1, 0 to -2, 3. And again, I use the formula so x is -1 minus t, y is 3t. Okay, so we substitute this in. For curve 1, I'm going to integrate 0 to pi sine of cosine t times negative sine t dt plus the integral 0 to pi cosine sine t cosine t dt. Here I let u be cosine t, so this is du. I change my variables here. Okay, minus a minus, so that's plus. Here I let u be sine t, so this is du. So I'm integrating cosine u from 0 to 0, and that's 0, so that just drops out. So far I have this. Okay, let me do C2, the curve 2 in blue. So I have my curve, so I'm going to integrate 0 to 1 sine of negative 1 minus t, because that's sine x, negative dt, plus 0 to 1 cosine 3t, 3 dt, because that's x prime dt. So u is negative 1 minus t, so du is negative dt. So I'm just integrating sine u from negative 1 to negative 2. I'm going to change my limits here. That's negative cosine u from negative 1 to negative 2. It's negative cosine negative 2 plus cosine negative 1, which is the same as cosine of 2 because cosine is an even function. Well, I'm not going to change this one because if you notice in green, that one, that's going to cancel with this one. Okay, let's move on. The integral of cosine is sine 3t divided by 3, so those 3's will drop out. Sine of 0 is 0. So I have this, this, and this. That's a plus. So my final answer is cosine 1 minus cosine 2 plus sine of 3. So if you have more than one curve, you just do each curve separately. Okay, let's look at 18. Okay, if you look at C1, you're looking in the book. I'm just going to say this. I'm not, well, okay, I'll write it down. The vectors near on C1 are pointing roughly in the same direction as your travel. So f dot t is positive since they're in the same direction. So the integral f dot t ds is positive, and that means the integral of f dot r prime dt is positive. On C2, as we travel C2, the vectors are trying to go opposite. So the forces go in the opposite way. So f dot t is negative. The integral is a negative, so that means the integral of f dotted with r prime dt is negative. Okay, in number 20, I'm going to use maple. F, y, z, x, z, x, y, and r is given by t, t squared, t cubed. T is in 0, 2. Okay. So no, I don't need maple on this one. Yeah, this one's pretty simple without maple because I'm just integrating over C f of r of t dotted with r prime of t dt. So I'm just going to integrate 0 to 2 of y, this is y, z, x. So multiply those, you get t to the fifth. xz is t to the fourth. xy is t cubed. I'm dotting that with r prime, which is 1, 2t, 3t squared. So really I'm just integrating t to the fifth plus 2t to the fifth plus 3t to the fifth dt, which is 6t to the fifth, which is just t to the sixth, which is just 64. Okay, so I don't need maple to do that. Now I'm going to use maple for the next one, though, which is 24. In 24, I have f is x over the square root of x squared plus y squared, y over the square root of x squared plus y squared. And c is the parabola y equal 1 plus x squared from negative 1, 2 to 1, 2. Now I'm gonna let, for c, I'm gonna let x be t and y be 1 plus t squared. Then t is gonna be going from negative 1 to 1. So, f of r of t is t over the square root t squared plus 1 plus t squared squared. I'm substituting these in. And r prime. And I'm going to dot those and integrate that. Okay, so maple will help us. First, I guess I'm going to graph it. So let's do with plots. I'm going to let f be the field plot of x over square root. Then I'm going to let the curve, which we said was t1 plus t squared from negative 1 to 1. Then I'm going to display them together. And you see, I can see the curve is a parabola. Now, on the right side, you can see the vectors in the quadrant 1, the vectors are going towards the parabola. As you travel the parabola left to right, In quadrant 2, the vectors are going opposite the direction you travel. So, what we're going to say here in quadrant 2, you're traveling this way, the vectors are going opposite, so f, the integral, will be negative. In quadrant 1, the parabola is going up and your vectors are going the same direction. So that will be positive. So your integral, and they're about equal, they're symmetric. There's some kind of symmetry. So your integral should be 0 over that curve. Now let's use maple to show that that actually is 0. We're going to integrate t over the square root of plus 2 times t times, this is f dotted with r, and I get 0. So when I integrate f dotted with r prime, I get 0. Just as what I thought, because again, if you look at this, as you travel the parabola in quadrant 2, the vectors are pointing in the opposite direction. As you travel the parabola in quadrant 1, the vectors are operating in the same direction, and those cancel each other out. Okay, let's look at 28. Again, we have a line segment, so we'll go ahead and get the parametric equations for it. Okay, then we're going to go from 0 to 1, because when you do that for a line segment, t is always between 0 and 1. We have x to the 4th okay, this is the vector, dotted with r prime dt. Okay, again, I'm going to use maple to do this. So I have the integral of 5 times Okay, plus 2 times the ln of 1 plus 4 times t plus 4 times the square root of 2 plus 2 times t squared plus and t equals 0 to 1. It's probably going to take a while to figure that out. And we get that in maple. That's the exact answer. And if we want to evaluate that, we get an approximate answer, 59,864. Okay, but it'd be good to use maple on that problem because it'd be really hard to integrate it otherwise. Okay, one more. Let's look at number 30. I have f is x squared xy, and the circle is radius 4. I'm going all the way around it, so the parametric equations are 2 cosine t, 2 sine t, t equals between 2 pi, and it goes from 0 to 2 pi because you go all the way around the circle. So we're going to integrate 0 to 2 pi, 4 cosine squared t, 4 cosine t sine t. We're substituting x and y into f, and then dotting it with r prime. And that works out to be 0. They cancel each other out. Now, if we look in maple, let's field plot it. Let's just go from -2 to 2. Let me call this D. And then we're going to plot the circle. Let's call that H. And so we see that the vectors are perpendicular or orthogonal to the level curves. So the vectors are orthogonal to the level curves, and they're pointing away. So the field, they're pointing away in quadrant 1, pointing to 0, 0 quadrant 2 and 4. So pointing towards quadrant 2 and 3 and pointing away in 1 and 4. But the vectors are perpendicular to the path, so the field does no work on the particle. The field never pulls the particle in the direction it's traveling, so that's really important. The field is not pulling the particle at all into any of the direction as it goes around the circle. So your f dotted with t is 0. So your integral here is going to be 0. There's no effect. Okay, so I hope this helps you.